So next we just want to look at some notes. These are things that you really want to, I hate to say memorize, but you really want to internalize these in terms of understanding and being able to apply. And even if you aren't able to write out from memory, this formula, the idea is that you can apply these principles in practice. And I'll give you guys a handout with a lot of these formulas and rules of integration. So I've used integration a couple of times as a term in previous examples, and that was a Freudian slip. I should have been saying antiderivative, but they're the same. They are the same. And so integration is the inverse of differentiation. Differentiation is the inverse of integration. We're undoing the process of taking a derivative. And so kind of once we introduce integrating polynomials, we kind of leave behind the terminology antiderivative, and we just talk about integrating or finding the integral. And so the idea here is that the derivative of a constant is 0, and so that means that the integral of 0 is equal to a constant. The derivative of a constant times x is equal to the constant, and so the integral of a constant is equal to the constant times x plus c. The derivative of a constant times a function is the constant times the derivative of the function. So the integral of a constant times a function is equal to the constant times the integral of the function. So we can pull the constant out if we're differentiating. We can also pull the constant out front if we're integrating. The derivative of a sum or difference of functions is equal to the sum or difference of the derivatives. Likewise, the integral of a sum or difference of functions is equal to the sum or difference of the integrals. Here is the power rule. Power times base down 1, and you can see that the integral rule is undoing this with sometimes constraints on the domain. And then we've got the trigonometry rules in reverse for integration. So the derivative of sine is cosine, the derivative of cosine is negative sine, tangent is secant squared, cosecant is negative cosecant times cotangent, the derivative of secant is secant times tangent, cotangent, the derivative is negative cosecant squared. So these are ones that you should already have memorized. If not, definitely learn these. And then it will be a lot easier to construct or reconstruct from memory the antiderivatives or the integrals. So the derivative of cosine is sine plus c. The derivative of sine is negative cosine plus c. The derivative of secant squared is tangent. The derivative of cosecant times cotangent is negative cosecant x plus c. And so we're just undoing differentiation for our trig functions. So then finally we want to look at transcendental functions. And so here we have e to the x, and I joke about this being my favorite derivative rule because the derivative of e to the x is e to the x. Well, so here's my favorite integral rule. The integral of e to the x dx is just e to the x plus c. The derivative of a to the x is a to the x times the natural log of a. And so then to undo that, we would have to have a to the x divided by the natural log of a, because since when I take the derivative, I multiply by this, I have to already have 1 in the denominator to cancel it out, if indeed I'm going to get just a to the x by itself. And so this is the same sort of rationale that we applied with finding the antiderivative of the power rule. and then of course plus our constant of integration plus c. And the derivative of natural log is 1 over x, and so the integral of 1 over x is the natural log of the absolute value of x. And again, that's because there are no restrictions necessarily placed on x. Here they tell us that x has to be positive. Well, that's fine. That's all well and good, but I know that because I was originally taking the natural log of x, and so x has to be non-negative and non-zero. It has to be positive. So the problem is when we go backwards, we're not necessarily mapping onto the set of all positive real numbers. Other than saying x is not equal to 0, which is the only constraint that I can place with this function, there's nothing that tells me x can't be negative. So for that reason, we have to have absolute values on the x when we take the natural log.